All right, so autism spectrum disorders, which we're doing in one of our labs, we are now going to talk about the genetics of autism spectrum disorders. Let's make sure I've got a little face. There we go. Hey, look at me. And then what we're going to do is we're going to zoom. Okay, so first of all, let's talk about the prevalence. In the United States, we have a very high prevalence. You can see Alaska over here. You can see the continental United States just has really, really, really high numbers. If you look at other countries, with very few exceptions, the rest of them have almost no numbers being reported at all. So what in the world is going on here? We'll talk about that. First, how do we understand our numbers here in the United States? Well, we have something called the ADDM. So the CDC and actually a number of other groups have put together a really cool monitoring program, and they looked at several communities since 2000 when we recognized that autism spectrum disorders were a thing we really needed to know more about, and that the prevalence was increasing. They set up these communities throughout the United States that they started to monitor. And they specifically made sure that all of the kids at certain periods would receive the autism and developmental disabilities assessments as part of this network. And so every 2 years, all 8-year-olds in the population were surveyed to determine how many have autism. They did it with 8-year-olds because more of the kids will have hopefully been diagnosed by that point. If you go earlier, it's often harder to diagnose. By 8 years old, it's 100% you can diagnose it, and there's also a really good chance that people will have been diagnosed by that point. As they started to do this, they found out that actually the prevalence was much higher than they thought, and it was increasing. So in those communities, they saw the numbers going up as they did this same process every 2 years. One possible explanation for why our numbers are so high is just we're picking up more cases because we're doing the testing. So as we get better at testing, maybe we're picking up more cases. Maybe that's explaining everything. But a lot of researchers have looked at it and said that does not make sense with the numbers we're seeing. It doesn't explain everything we're seeing. So some people have said, well, we're just overdiagnosing, or we're applying the diagnosis more broadly, especially with the DSM-5. Maybe we changed something and now we're picking up even more stuff. And people have gone in and done the research, and that doesn't explain everything. It might explain a small amount, but it definitely doesn't explain everything. Some people have argued that with successfully earlier diagnosis in each succeeding cohort of children, including recognition in nursery, preschool, that could possibly be affecting prevalence but not incidence. So what's happening is the prevalence numbers are going up because every year you're picking up a larger population sample size because you're getting all the people you already got. You're also getting earlier and earlier pickup as the methods get better at picking up the preschool age kiddos. So that's artificially inflating the numbers, but the incidence isn't really changing. If that was the case, then what would have happened is once we got to the point that we were testing kids really early, 3 years old, and we're not getting any earlier, our numbers should have started to go down, but they have not. So one thing people have said is that it could be diagnostic substitution. What that means is, as ASD has become something we're more aware of, and as more and more people get better and better at measuring it, and there's more tools available, when you have a kiddo who you need to diagnose, if they have anything that would have previously been diagnosed under some other term that can now be diagnosed under autism, you're gonna put them in that bucket. That can actually explain some of what we're seeing, especially when you have some labels like Asperger's syndrome that have disappeared, and now those kids are being put directly under the autism spectrum's label. They were already part of the spectrum, but now they actually have the autism label. It's possible that that is causing some of what we're seeing. But again, it can't explain all of what we're seeing. There's something else going on. So, before we get into all of this, I want to quickly just address one or two things. Vaccines do not cause autism. that's it. That's really all you need to know. There's so much research on this. We could go into the history, and I really hope that in the autism class, Dr. Self will talk about that more. In the critical thinking class, I believe they'll talk about that more. A lot of you hopefully at some point have had time to learn more about how there was that study that turned out later on to be falsified, that was published in the Lancet, that basically launched all of the pseudo-vaccine autism links. Even after that was retracted, even after the researcher lost his license, even after it came out that lots of the data was falsified and the sample size was much smaller, and even after massive amounts of money and massive amounts of researchers have done huge studies all over the world and found that actually that is not the case. Especially here in the United States, there is a huge number of people who strongly believe that vaccines cause any number of disorders, especially autism, and that there is any number of possible mechanisms and any number of possible research studies proving this. It's not true. And the problem I have is sometimes when we're talking about topics, do I wade into the politics of it? Do I do a false equivalency? Do I do a little bit of whataboutism? Or no, it's not appropriate to do any of that when we're talking about a medical topic, just as it would not be appropriate for you to do trepanning as an evidence-based practice. That's where you drill the holes in the head to let the bad spirits out. Just like you cannot do reverse phrenology, which is where you hammer on someone's head to help cure their personality defects. Just as ear candling, where you stick the candle in your ear and light it to get out all of the earwax, is not a real thing. It's a pseudoscience. And just like, I can go on and on and on. There's so many crazy things. You can ask audiologists. Honestly, you can ask Dr. Hull, and he could probably tell you that a lot of audiologists, until fairly recently, would say, "Oh, yeah, you can help get the earwax lessened by blowing smoke in the kid's ear." I don't know if that's actually where the term "blow smoke up your smoke in your ear." I have no idea where that came from, but it's a real thing that people used to do and thought it had medicinal benefits. Pseudoscience is pseudoscience. We are evidence-based practitioners. We will be medically licensed practitioners once you guys finish your praxis, right? At a certain point, once a certain amount of evidence happens, we have to say we accept the mass consensus as medical practitioners in our field. Now, if you go on to become an expert in autism and you want to put your entire everything on the line to do another research study and prove that everyone else is wrong, then you go for it. But right now there's a lot of people way higher up on the totem pole than you in terms of experience and expertise, and there's a massive population of researchers and scientists and speech language pathologists and audiologists, and the consensus is does not cause autism. So that will be on the test. That's something you need to know. There's no ifs, ands, or buts about that. I spent way too much time on this. I just want to be clear. Vaccines do not cause autism. Many studies of the highest evidence level have examined this. There is no link to vaccines and between vaccines and autism. There is no link to vaccine ingredients and autism. All right. Incidence. 1 in 68 children is estimated to be born with some form of ASD. I have not checked to see if that's been updated in the last year. That was the number I had when I was putting together this slide. But 1 in 68, that's a huge number. This number has been relatively stable since monitoring under new guidelines in 2010. So it's not because of just changed guidelines. From the 90s to 2010, the United States saw a huge increase in the number of diagnosed cases, and some of that may be a result of diagnostic substitution, more precise criteria, increased service availability, and increased awareness, and better testing teams. When we look at the incidence, there is a difference between boys and girls. Boys are 4.5 times more likely to be on the spectrum. Autism co-occurs with a huge range of other things. Just in terms of percentages, you can see that it's very commonly co-occurring with certain syndromes like Rett syndrome, Cornelia de Lange, I'm not sure if I said that right, syndrome, tuberous sclerosis complex, Angelman syndrome, Fragile X syndrome, neurofibromatosis. So these are the percentage of people with different genetic disorders who also have autism. So 22% of people with Fragile X also fall in the spectrum. 61% of people with Rett syndrome also fall in the spectrum. So you can see there's some very strong co-occurrences suggesting, first of all, that there's a genetic component going on, and second of all, that whatever is happening in autism is related to some of the things that are happening in these other systems, although it's hard to say what exactly. The co-occurrence of one or more non-ASD developmental diagnoses is 83%. So 83% of people with ASD will have some other non-ASD developmental diagnosis. The co-occurrence with a psychiatric disorder of some sort is going to be about 10%. So genetic clues. What is the genetic component? Well, we can always go to twin studies. Those are very informative. We've talked about them briefly before. If we look at identical twins, if one child has ASD, the other will be affected about 36 to 95% of the time. So they've done a bunch of studies, the percentage ranges, but there's definitely a genetic component. In non-identical twins, it's 0 to 31% of the time. So again, with the twin studies, we look at fraternal twins and identical twins. Identical twins share DNA, so if we expect that something has a genetic component, there's going to be a much higher likelihood that you'll have the disorder if your twin has it. Whereas fraternal twins do not share DNA, or at least they share just the same amount of DNA as any other siblings, and so the genetic component is going to be reduced, or at least the genetic similarity is going to be reduced. And that's exactly what we see here. That suggests there is definitely a genetic component. Now, we can also do something called a simplex case that we have not talked about before. So a simplex case is when you look at a family, you find a kiddo who has the disorder, but none of the parents have it, none of the siblings have it, no one else in the family has it. When you see that, then you're probably looking at a de novo mutation, so a new mutation, or something that is probably not being caused by inherited trait. It's some new trait that has happened either through, well, any of the sources of genetic variation that we've talked about at the individual level. So the crossing over, the fertilization, the independent assortment. If this trait resulted in that individual because of one of those things, and we then DNA test that kiddo and compare them to their family, the things that are different in them we can flag, and those are the likely candidates for genetic differences that could be causing autism, right? So dad doesn't have autism, mom doesn't have autism. We know that Bobby has autism. We look at their DNA, and obviously mommy and daddy have lots of things that are different, and so does Bobby, but if we flag all of those differences, and then we do this in a lot of other families, and they did this with 4,000 people from 1,000 different families, what you will end up finding is that the differences that are flagged in the individuals with autism overlap in some cases. And if you can find that overlap, then you have a really good idea which genes might be responsible. You can also do familial studies, so parents who have a child with ASD have about a 2% to 18% chance of having a second child who is affected. And affected individuals who have an 8% de novo mutation rate they have an 8% de novo mutation rate compared with a normal 2% rate. Affected individuals show more copy number variations than their siblings. And here the affected should be the individuals with autism show more copy number variations. So copy number variations might be one of the mechanisms. Remember, copy number variations is one of the things that can lead to some of the other patterns we've talked about, like stuttering alleles and anticipation. So when we look at copy number variations, because of chromosomal changes, we can end up with variations in the number of copies, and it can happen at the section level as well as just the short repeats. So each section probably has 5 to 10 genes, and you can sometimes get copies. So here C can be copied. See how there's 2 copies of C? So we talked about stuttering alleles. You can actually get copies of regions, and that will include multiple genes. And in people with autism, we tend to see more of those copy number variations, or at least in some people with autism. ASD tends to occur more often in people who have certain genetic or chromosomal conditions. We talked a little bit about those comorbidities, and about 44% of children identified with autism spectrum disorders have average to above average intellectual ability. So that's interesting. Has something to do with the way the brain is developing, possibly. Children born to older parents are at higher risk for having autism spectrum disorders. That's interesting. And then boys are 4.5 times more likely than girls to have autism. There are different ethnic groups that have different variation in terms of autism spectrum disorders. So if you look at white Caucasians, you're going to see us. I don't like the term Caucasians. Let's say it's problematic. We don't use some of the correct terms. So, for example, if I were to say black, that's not actually a genetically descriptive group. What I could say is I could say American, and then I could say either African Americans, but that's specifically black people who have some African ancestry. You can also have Caribbean African, right? So you can have American Caribbean African, which is different than American. Because the population in the Caribbean was there for a long time, and some populations came directly over from Africa, the genetic variation in those two groups is distinct, even though they're both black. And you have a lot of other populations you can talk about. So we have to be really careful when we use a term like Caucasian, which is not actually a really good term when we apply that to populations. But if we look at people of Western European descent, if we look at people with Native American descent, if we look at people with Eastern European descent, if we look at people with Western Indian descent, each of those populations is going to have a different prevalence of autism when you look at the groups here in the United States. If we then were to look at other countries, it's going to be different still. So the Western Indian population within the United States, these are Americans with a Western Indian background, right? They're going to look very different than the Western Indian population that lives over there in India. So we need to be aware of that variation, and that sometimes when we're looking at these prevalence and these numbers, it's not very descriptive of minority populations. All right, so they're doing a whole bunch of cool research. They found about 65 genes that are identified now, highly likely to be related to autism. They actually have done a new study recently that I think has increased that to something like 300. There's hundreds of others being studied. Mutations in these genes can often be de novo mutations. So brand new mutations seem to happen pretty often, especially because of those increased copies. And there are multiple pathways that can be going on. These genes often seem to be related, and there's two big families. They seem to have a lot to do with neural development and neuronal activity. So how the neurons in the brain communicate with one another. There's a whole bunch of genes associated with that. So maybe they change the way neurotransmitters are received, or maybe they change how quickly the synapses grow together. That's neuronal activity. But they also seem to have a lot to do with neuronal development and neuronal plasticity. So as the baby's developing, how is the brain put together? And the interesting thing about that is that means some of it's dealing with the genetics that are more the baked-in hardwired genetics of your brain, and some of it's dealing with the genetics that have to do with software that can be sort of changed behaviorally and functionally. There do appear to be some genetic factors that can provide protection. So we've talked about things like imprinting before. Females with autism tend to have more mutations and more severe mutations before they show symptoms. So think about something like Huntington's disease, where you have to have a certain number of copies before you have an effect. In autism, women with the same number of copies as men are less likely to show the symptoms. They have to have a lot more copies built up, so they have some sort of protective factor that is very, very interesting. So let's do some quick math. If we were to identify a single gene highly associated with autism, only 1% of the population of individuals with autism have that mutation. So we find one of these genes and then we go and test everyone. On average, only about 1% of the people with autism are going to have that. So what does that tell us? Well, there's complex heterogeneity. It's polygenic. There's a lot of genes involved, and you can have different combinations of them. And every individual is going to have a completely different, not every individual, but lots of individuals are going to have very different makeups that result in something we recognize as autism spectrum disorders. The other thing to keep in mind, if we identify a single chromosomal anomaly or a copy number variation, those bigger mutations that we're looking at associated with autism, only 15 to 20% of the population of individuals with autism have that mutation. So we look at, instead of a single mutation like a base pair mutation, a letter mutation, we're looking at those copy number variations. We find one that's associated with autism, and then we look at the whole population. 15 to 20% of the population might show that. So those copy number variations associated with autism are very important, and they seem to encompass more of the genetic variation that we're seeing, but it still doesn't explain anywhere near everything. So what that means is every single case is going to be different. They're going to be genetically different. They're going to be functionally different. That's why it's a spectrum, because there's so much complexity going on. The basic summary and the things that I want you to know: there is a genetic component. It is polygenic. Many of these genes are pleiotropic, and you should know what each of those things are. There are many genetic pathways that can result in something that looks like autism spectrum disorders. Penetrance and expressivity play a role. That's what's causing some of those protective factors. Epigenetics plays a role. That's also probably causing some of those protective factors. And also maybe is affecting some of the inheritance. Mechanisms like imprinting are likely involved. There are chromosomal genes at work, novel single genes at work, and heritable gene mutations at work. So we basically took all the complicated genetics we've talked about this semester and we've packed it into one family of disorders. We're still learning more. Very, very true. And that was it for autism spectrum disorders. If you know these things, you're in a really good place. I would also probably ask you, what's the relationship between vaccines and autism? And there is only one acceptable answer to that. I would probably also ask you, how do we know this stuff? Give me an example. And you could say something like, we've done twin studies, or the ADDM has studied communities across the United States, or you could say any of the other things we talked about. There's a bunch of different things you can say. So I might ask you something like that gives you a lot of options, and you just need to pick one. And that shows me that you listened to this and you understood it, but you don't have to memorize things. Since your tests are always open book in this weird format we're in, I could ask you something else, but those are the basic questions I'm thinking about right now. Thank you, guys.